Hi, this is Miss Logan. Today I'll be covering momentum. This is Michigan Husky P 3.5 and NGSS HS/PS2/2 and 3. Alright, so you probably hear momentum a lot, especially in sports, such as, wow, that team really has momentum this year. But momentum is defined a little bit differently in physics. So this is simply mass in motion. Okay, momentum depends on two things, which is mass and velocity. This is not to be confused with Newton's second law, which is F equals ma. You will see in a moment how similar these two things actually look. All right, so our equation for momentum is P, which stands for momentum. In physics, we often run out of things to use for our abbreviations, so we use P for this. M stands for the mass of the object, and this is going to be in kilograms, and velocity, which is going to be in meters per second. So the big question is, what is the unit for momentum? It's kind of weird. It's kilogram meters per second, which we get from multiplying mass times velocity. As you can see, it looks kind of similar to F equals ma. They are both linear relationships, which you can tell because they are multiplied by each other. All right, so let's think, is this a vector or a scalar? Take a minute to pause the video and think about, is velocity a vector or a scalar? Well, if you said vector, you were correct. Momentum is a vector, all right? So it's always going to have a magnitude plus a direction. Okay, so let's practice. So a ball with a mass of 6 kilograms is traveling at 5 meters per second. What is the ball's momentum? So what we're looking for the momentum, which is P. We are given the mass, which is 6 kilograms. And we're also given the velocity at 5 meters per second. What is the equation we're going to use, or our relationship? That's P equals mv. So let's multiply 6 times 5. That's going to give me 30 kilograms meters per second. Don't forget those units, those are super important. All right, let's do a listing of a problem. So a car's momentum is 4,000 kilogram meters per second. It is traveling at 4 meters per second. So what is a car's mass? So what I'm looking for is my mass. What am I given? I'm given the momentum. And I am also given the velocity. Remember, traveling at is going to give me velocity. So what equation am I going to use? If we look at my relationships, P equals mv, I can just make that really easy for myself, and m equals P over V. All right, so let's do a little bit of math here. 4,000 divided by 4 is going to give me a mass of 1,000 kilograms. Sorry, I ran out of room there. Once again, super important about my units, always going to be kilograms. All right, so for my last sample problem, I have a ball of the mass of 6 kilograms and is traveling at 0 meters per second. Do I have any momentum? Let's think. P equals mv. I have a mass of 6 kilograms times a velocity of 0. I have 0. So anytime I don't have any velocity, I don't have any momentum. I'm not moving anywhere. Think about if you're just standing there, not moving, you're not going to have any momentum to move. All right, let's move on right now and talk about the conservation of momentum. So as I said before, conservation of momentum is Newton's third law. The momentum at the beginning of a collision is going to be the momentum at the end of a collision. That's why it's opposite. Remember, equal and opposite. If you know Newton's third law, you also knew the conservation of momentum. Let's see how this acts in real life. Okay, so when we're looking at any point with momentum, we're talking about collisions. We have two different types. First, we have an inelastic collision, so when an object sticks together after the collision, and elastic. They're going to bounce off each other after the collision. So in this situation, my first one, think about, is this one going to be a inelastic or elastic? If you said elastic, you were correct. Up here with the grandma and the kid, this is an example of inelastic, and this football player tackling another one is inelastic. We are mainly going to focus on inelastic collisions. All right, so let's start out with a problem for momentum conservation. It may look challenging, but really use your intuition about this. Remember, momentum conservation is Newton's third law. Equal and opposite reaction. Opposite is because of that negative sign. So you and your friend stand facing each other on ice skates. Your mass is 50 kilograms and your friend's mass is 60 kilograms. When you push off each other, your velocity is 4 meters per second. What is your friend's velocity? So this is an elastic collision. You're pushing off of each other. All right, so your mass is 50 kg times 4 meters per second. However, on the other side, your friend has a mass of 60 kg, but we're looking for that velocity. So on your side, we have 200 equals negative 60 times v. Remember, we're looking for velocity. So we're going to divide on both sides. I'm going to get my velocity at negative 3.3 meters per second. All right, really simple algebra to get there, and we figured out from this elastic collision what was going on. Okay, so our big ideas, momentum is the movement of mass, which gives us this wonderful equation. The conservation of momentum states that momentum after a collision is equal and opposite to the momentum before, which is basically just Newton's third law. And we have an equation for that too. Then we have two types of collision, inelastic and elastic. So please write down any questions you have and we will go over them in class. Thank you.